Hi everyone, in this video I'd like to talk about a very special right triangle, one that is called an isosceles right triangle or right isosceles triangle. But more specifically, the angle measures in it are, hence the name right triangle. There's a right angle which is 90 degrees, and since it's isosceles with two equal sides, it's also going to have two equal angles of 45 degrees each. So it's really called a 45, 45, 90 special right triangle. Okay, so just to give you a little kind of background idea on this, let's take a look at these two isosceles right triangles. On the left, one of the legs is 5, which means automatically the other leg is 5, and then the same thing on the right. Since one leg is 8, the other leg is 8. Now I've gone ahead and used the Pythagorean theorem for each of these to find the missing side lengths, right? So if I take 5 squared plus 5 squared equals c squared, as you can see here, if you want to pause, the result ends up being 5 radical 2. So if you'd look, we have legs of 5, 5, and a hypotenuse of 5 times radical 2. Similarly, on the right, you'll see we have 8, 8, 8 radical 2, and this will happen every single time you try to use the Pythagorean theorem for a 45, 45, 90 right triangle. Okay, so I want to come back here and talk about taking shortcuts and using the rules for this specific case. If you take a look, if you know the leg, and I'm just going to use x as a variable, right? But for example, if it was, I don't know, say 17, then you'll know the other leg is also 17, and you can find the hypotenuse by simply doing 17 times radical 2. All right, so that's the rule. The magic number is radical 2. If you want to go from the leg to the hypotenuse, you multiply by radical 2. If you want to go backwards and take the longer side back to the shorter side, you divide by radical 2. So nonetheless, your magic number is radical 2. So let's look at these two examples here, right? So I'll start off by the one on the left here. What I'm going to do is I'm actually going to go write the rules from above. I'm going to go write them on the figure itself, and I think that's a good idea in the first couple days of doing this. So the rules are x, x, and x radical 2. As you can see, we have two equal legs. What do we do to the leg to get the hypotenuse? We multiply by radical 2. So long story short, you don't need to use the Pythagorean theorem anymore. We can just simply say that your hypotenuse is 12 radical 2. All right, on the right here, it's kind of backwards, but it's still they all have the same situation. They all have the same pattern. So I'm going to call this, actually I keep using x. Let's try to use something different here. Let's just say, I don't know, it's side, side, and side radical 2. Well, let's think. What do you do to the hypotenuse to go back to the leg? Now, a lot of students will say, well, we're just going to, quote unquote, get rid of the radical 2. And you are, but mathematically what you're doing is you're taking 5 radical 2, the hypotenuse, and dividing by radical 2. Now, that's nice because the two radical 2's will divide out, leaving you just with 5. Okay? All right, now, they don't always stay, perfectly straightforward. This one I think is a little tricky, so let's take a look. If you notice, there's a little red flag going off in my head saying, wait a minute, this is usually the side that doesn't have the radical 2. But it doesn't matter. We still use the same strategy, right? What do you do to the leg to make it bigger or turn it into the hypotenuse? We multiply by radical 2. So I'm going to take 9 radical 2 and multiply it times radical 2. Now we've done this extensively. Radical 2 times radical 2. Yes, it's radical 4, but we should be skipping that step, right? Radical 2 times radical 2 is just 2, giving us a hypotenuse of 18. Okay? All right. The last kind of straightforward example with like one 45, 45, 90 triangle is this one here. This one's where it gets a little challenging. All right. Again, I got a little red flag kind of going off in my head right now, a little alarm saying, wait a minute. This is usually the side that has the radical 2. Now, it doesn't have to, right? You could have a hypotenuse that is 8 units long, 8 inches long, right? But we just stick to the strategy, right? What do you do to the hypotenuse to go back to the legs? Well, we want to make them smaller. Therefore, we're going to use our conversion number, our magic number of radical 2. So what I'm going to do is I'm going to take the hypotenuse, 8, and I'm going to divide it by radical 2. Now, based on our previous studies, we should be saying to ourselves, uh-oh, wait a second. I have a radical in the denominator. I need to rationalize. So what I'm going to do is multiply by radical 2 over radical 2, and that's going to give me 8 radical 2 over 2. But we can divide. So 8 divided by 2 is going to give me my leg, which is going to be 4 radical 2. All right, if one leg is 4 radical 2, so is the other. All right, so I want to finish up with two kind of like, extension ideas here. First of all, I'd like to look at kind of two adjacent 45, 45, 90 right triangles. So I've highlighted them in blue and green. Now, if you notice, I do know one of the sides down here, so I'm going to take my time here and I'm going to write my rules. I'm going to say x, x, and x radical 2. So when I go from leg to hypotenuse, I'm going to multiply. So let me go ahead and, actually, we should know that the legs are equal. So I'm just going to have 7 and 7, and then times radical 2 is going to give me 7 radical 2. All right, so I've labeled all three sides in the blue triangle. Now I'm going to move on to the larger green triangle. Now, what used to be the hypotenuse for the blue triangle is now the leg for my larger green triangle. So again, I'm going to take my time here. I'm going to write my rules on here. This is now x, x, and this is x radical 2. All right, so now I'm just going to switch colors here just so it matches up here. So I'm going to go green. So 7 radical 2 is one leg. That means 7 radical 2 is the other leg because they're equal. And then, guys, just like we just practiced, in order to go from the leg to the hypotenuse, we're going to take the leg times radical 2. It's okay if it already had a radical 2. We're still making this bigger by multiplying by radical 2. So I get 7 times radical 2 times radical 2, which is 7 times 2. And our final answer for the hypotenuse would be 14. Okay, finally, I'd like to talk about a special figure, which is a square. Now, in all squares, you have 4 equal sides, all right, and 4 right angles. But this works out nicely for us in our special right triangles idea because, think about it, when we draw our diagonal, right, it's going to bisect each of these angles. Now think about it. What is 90 bisected? Well, that's going to give us 45 and 45. 45 and 45. Okay? So this is nice. So I'm going to have 2 45, 45, 90 special right triangles. I'm just going to use the same colors I did before. I have a green one and I have a blue one. Okay, but they're both congruent. So what I'd like to do is just give you an example. Let's say, I don't know, that the diagonal is 10, and I want to find the perimeter of the square. Well, that means if I want the perimeter of the square, I'm going to need to know each of the side lengths. But think about it. This is a 45, 45, 90, special right triangle. So I'm going to focus on the green one here, and I'm going to say, hey, what do I do normally to go backwards from the hypotenuse to the leg? We are going to divide by radical 2. So if I do 10 divided by radical 2, need to rationalize. I'm going to end up with 10 radical 2 over 2, and hopefully you're starting to feel a little bit more comfortable with this. That's going to give me 5 radical 2. If we want the perimeter of any figure, we add up all the outsides. But wait a minute. All of these lengths are 5 radical 2. So therefore, my perimeter is going to be 4 of those 5 radical 2s. My 4 times 5 radical 2 is 20 radical 2. All right, hopefully all of these examples are helping you feel a little bit